The purpose of this video is to describe how to configure and send different DICOM images. That includes individual DICOM images and complete DICOM datasets, typically to a PACS or teleradiology destination. This video was recorded on CubeVue version 2809. Some of these features may be available on earlier versions of CubeVue as well. Let's start off by configuring a DICOM send. Typically will be to a PACS destination, possibly to teleradiology as well. First of all, select any patient, then right-click on Recon to select DICOM send. The DICOM sender window will then appear with its default information here on the left. This default information will need to be replaced by information provided to us by our IT or PACS administrator. Whatever name they provide, and we're just going to use test PACS as an example, we would enter here. The host is typically the IP address on the local network, again provided to us, whatever port they give us. Local AE, in this case by default, is the CubeVue software installation that we have on the computer that we're working with right now. We can change this to CubeVue 1, CubeVue 2, etc. if there's more than one software package that we might be sending from. Or we could even change it directly to whatever the workstation is provided to us by our administrator. So for now, we're just going to label this CubeVue 1. And the remote AE title, where we're sending all our DICOM slices to, let's just change this again to test PACS. We'll then create a new DICOM send destination. Notice how it's highlighted. What if we should happen to have more than one PACS destination that we might be wanting to send to? We can create additional DICOM send destinations and store them here as well. Let's just update some of this information. And create a new one. We now, if you look over here to the upper right, we can switch back and forth between the two different PACS destinations, or by pressing the Shift key and selecting them both, we can send to both PACS destinations at the same time. If at any time you want to update some of the information, let's just say for example test PACS 2 has been given a new IP address, what we need to do is just swipe over the information after selecting the PACS destination, update the information, and then click on Update. Our changes will then be saved, and then anytime we select test PACS 2, in this case, it will then send to the new and updated IP address. Now that we've configured our DICOM send destination, let's take a look at some of the options available to us for sending images or series of images to that destination. For example, if we scan a patient and we realize that the images we have created are not optimum for viewing the anatomy that we want, for example, because the patient was not properly oriented, one of the things we can do is we can reorient the patient by rotating the data set, then going to Save Volume as DICOM, and the DICOM volume creation window opens. We now have a number of different options and selections available to us, which will enable us to send the optimum images to our DICOM send destination. First, we need to determine how thick we want our slices to be. The slice thickness will always be a multiple of the original voxel size at which the patient was scanned, which would either be 0.3 or 0.37 with the pedCAT. So for example, if we want 3mm slices, we can either go just a little bit below or a little bit above, getting fairly close to 3mm. If we want 2mm thick slices, again, adjust the slider until you get as close as desirable to 2mm thick slices. Note that slice spacing, at least in this version of CubeVue 2809, is not adjustable. Right now, the slices where one ends, the next one will begin, so there is no spacing between the different slices. Next, we determine which planes we want to send reformats from. So we look at the axial views, which are in general outlined with the color red, the coronal views, which in general are outlined with the color blue, and the sagittal views, which are outlined with the color green. We have corresponding checkboxes for the red plane, or axial if you will, blue for coronal, and green for sagittal. Notice as we select each checkbox, we also have a description for each of those series. They all start out saying axial, but we can change the series description. For example, we'll leave red as axial because it does represent, in this case, the axial plane. But in the case of the green images, that's actually coming from the sagittal plane. So I'm just going to change that. And then the blue images in general are coming from the coronal plane. So I'm going to change that as well. Now, once we click on Start, what we're going to do is we are going to create an axial, sagittal, and coronal series of images at the specified slice thickness with these given names, with the orientation that we have changed at the time we selected to create a new volume. Now, this volume is going to be created and saved on the local drive of the computer where CubeVue is installed. If we want it to be sent to the PACS, we must check Send New Volume. Again, you must send new volume. That box must be checked in order to start sending that volume we have created. After we create several different volumes, they're going to start taking up space on the hard drive of this computer where CubeVue is installed. So if we don't want them to keep accumulating on that local hard drive, we can also check and delete the new volume after it's sent. Now, when we originally scanned this patient, the toes were not pointing straight up. We reoriented the data set so the patient's toes are now pointing up. If we would like to change the information in the DICOM header where it says this is the orientation in which the patient was originally scanned, we can check the normalized data set rotation box. It's going to ask you, has the axial view been rotated so that the foot is pointing straight up? Would you like to continue? If you click yes, then there will be no record that this patient was originally scanned in a different orientation. This is not something that is normally preferred, but the option is available to you. Now, when we open these images in a third-party viewer, such as a PACS viewer, and we find that we have to regularly adjust the window and leveling, for example, they're always too dark or always too light, we can check this box that says Set Window and Leveling to, and make some adjustments to the default window level settings. That's going to go into a DICOM tag. So we're not actually changing the image itself. What we're telling the viewing software is if you use these window level settings, you'll have a minimum amount of adjustment to do once you've opened images from the pedCAT. So now we've selected all our options and we're ready to do a DICOM send. We want to double check that our DICOM destination has been properly selected. Remember, early in the video we configured our DICOM destination. So for example, if we just want to send to test PACS, we make sure that is selected and then we click Start, and then a send process will begin. First, we create the new volume. We create the three different reformats, axial, sagittal, and coronal. And then we actually send it to the selected DICOM destination. Some other DICOM images that we can create and send from CubeVue software is a series of images that represent the 3D rendering, rotated about different planes. First thing that you want to do, of course, is you want to make some minor adjustments to make sure that the 3D rendering image that you have on display here is the best possible representation. Then open up the Create 3D Frame Sequence window, the video creator. If you're sending to a PACS system, you want the output to be DICOM. This will create a series of DICOM slices rotating about either the x-axis, the y-axis, or the z-axis of the 3D rendering. Be sure to also check the Send After Save box. That means that the images that you create on the local drive of this computer will not only be saved there, but they will also be sent to the DICOM destination that you select. The number of images by default that we are creating is 36 in the series. We can also change that. 36 frames means that roughly every 10 degrees we're going to be creating a new image and include that as part of the series. If we change that number to 72 as example, twice as many frames, that means roughly every 5 degrees we're going to be creating a new image and saving that as part of the series and sending it as well. So let's actually attempt to create and send a series. For example, rotating about the x-axis, let's start to create and then send a series. Since we selected 72 frames, roughly every 5 degrees we're going to create a new image, and then we're going to include that as part of the series, which is what we're doing now. And then we'll attempt to send it to the DICOM destination that we have created and configured. All right, let's see what the Y sequence will look like in its creation. We flip up the heel, and then we slowly rotate about the Y axis. Once the series of images is created and we update the local database, we then attempt to send. And the Z rotation in its creation will look like this. Now that we've finished creating and sending the sequences, let's take a look at what those images actually look like. Notice that we have created an X, Y, and Z sequence. Looking at the X sequence, for example, there are 72 images in it. And opening it up, we see what looks like a representation of the 3D rendering. As I scroll through the series of images, as the images advance, it looks like the volume rendering is there rotating in the X orientation. I can rotate it and stop it at any point just by advancing through the images in the series. I can also open up any of the others, for example the Z sequence. And again, this appears to be rotating about the Z axis. We can also DICOM send individual images. For example, if we want to DICOM send this particular image, the process is a little more complicated. We need to go save as DICOM. Then when we go back to our patient list, we see this single image. That's the one that we just created. We need to right click on it and then do a DICOM send. Again, making sure our destination is correctly established. Also, by saving screen as DICOM, we are going to save all 4 of these images simultaneously in a single image. That too, you'll need to go back to the patient list, select the single screen image, and send that one. And finally, if we go to the InStack tab and we want to send any one of these images, one of the first things you should do, of course, is to make sure that all of your images are optimized before you send them. Make any necessary adjustments to window leveling, zoom to largest possible size, etc. Then go to your check mark over here. Whichever image you want to send, make sure that that particular image is checked. If there's an image you don't want to send, for example, the Saltzman PA left foot image, remove the check mark and you'll only send the 4 remaining images. Once you have selected and optimized all of the InStack images that you want to send, you then click on DICOM Send. Make sure you have selected the correct PACS destination and then start the send. And a quick troubleshooting tip. If your send is successful, you will receive a message down here in status that says complete. If you get any type of error message, more than likely, especially if it says association request failed, either you have inputted the wrong information that was supplied to you by your IT or PACS administrator, or something on the PACS end of things, on the DICOM destination, has not been prepared to accept images from this particular workstation. Either way, it's typically not a CubeVue problem, especially if an association request failed, rather misinformation or miscommunication between different elements within the local network and the PACS system. This concludes our video for CubeVue software training for DICOM Send. All of the features available in this video are available in the latest version of CubeVue at this time, which is version 2.809. If you do not have CubeVue version 2.809, be sure to contact CubeVue Technical Support. They will be able to send you the files and instructions on how to install the newest version of CubeVue software on your different workstations in your practice.